Let's take a look at percent composition. So we know the mass of a compound by calculating the molar mass. Well, we know that a compound is composed of more than one element. And so what we can do is we can calculate the mass percent of each element in a compound. So here I have a chlorofluorocarbon, and so we can calculate the mass percent of the chlorine in this chlorofluorocarbon by taking the mass of two chlorines and then the overall mass of the chlorofluorocarbon and then multiplying by 100. As mass percent is just the mass of the part over the mass of the whole times 100. All right, so here's a couple examples. So sodium nitrite, okay? This is it's a food preservative. So if you hear like people talk about nitrites, this is the preservative that we put in there. It's not the greatest substance to eat, but it's in a lot of our preserved meats and stuff. So let's figure out the percent composition for each element in sodium nitrite. So to start off with, we do need to know the mass of the whole before we look at the masses of the parts. So the molar mass of the whole, we're going to take sodium 22.99, 1 nitrogen 14.01, and then 2 oxygens at 16. So our whole here is 69.00 grams per mole. Okay, so let's look at our mass percents. So for sodium, we only have one sodium. So 1 mole of sodium is our 22.99 grams. We've got our 69.00 times 100. And so we get 33.32% sodium. Okay, our nitrogen, we only have one of them, so 1 mole of nitrogen is 14.01 grams. Our whole is our 69 grams times 100, and we get 20.30% nitrogen. And again, this is by mass, okay? And so nitrogen has a lower mass than sodium does, so it's a lower percent by mass. The rest of it should be made up with our oxygen. So our oxygen, okay? Now oxygen, there's 2 of them, so I'm going to do 2 times 16 over our 69 times 100, and we'll get 46.38% oxygen. Okay, they should be 100, so if I added these 3 up, we should get to 100%. All right, let's try one more. All right, so here's stearic acid. It's a really long compound there. This end of it up here is where it's acidic, particularly that hydrogen is what makes stearic acid an acid. All right, so let's get the molar mass of our whole. Okay, so we have 18 carbons, so 18 times our 12.01. We have 36 hydrogens, so 36 times our 1.008. And we only have 2 oxygens times our 16. So we get 284.468 is the mass of our whole when we have 1 mole of it. All right, so carbon, 18 moles of it times 12.01 over our 284.468 times 100, we get 75.99% by mass carbon. Now hydrogen, there's 36 of them, but remember hydrogen only has a mass of 1.008 grams for every mole. So even though we have 36, we're not going to have a huge percent of our mass composed by the hydrogen. So we'll take our 36 times our 1.008 divided by our 284.468 times our 100. And indeed, we only get 12.76% hydrogen. Okay? Now, oxygen, even though oxygen has the heaviest mass of the three components of stearic acid, there's not a lot of oxygen. There's only 2 oxygens in each stearic acid. So we're not going to have a large percent by mass of oxygen either. So I have 2 of them times the 16 over the 284.468 times the 100, and we get 11.25. Okay, and so that's how we figure out percent composition. It's just looking at the percent by mass, and all a percent by mass is mass of the part over mass of the whole times 100 to make it a percent.